This is my second video for successive differentiation. Already I published one video, nearly 10 problems for 2021, also 2022. Okay, today is my first question, successive differentiation of the calculus problem. If y equals square root x, if y equals square root x, sine square root x, y equal sine square root x, show the answer 4x d square y over dx square plus 2 dy over dx plus y equal to 0. My second YouTube video, so subscribe please, viewers, subscribe these new viewers, then you can get a lot of attractive problem solution of pure maths as well as applied or the combined maths. So if I show this answer, this is given, show that answer. So what is successive differentiation? In this case, differentiate first time, again differentiate second. That's called d square y over dx square. So if I write the first differentiation, dy over dx. So what is sine differentiation? Cos. Hereafter, in a function, square root differentiation, 1 over 2 times square root, right? First trigonometric function, trigonometric sine differentiation cos, in a function square root 1 over that. Hereafter we take cross multiple, here 2 times root x dy over dx, that's equal to cos square root x. So next we can differentiate once again, right? Next you write differentiate respect to x again. Differentiate with respect to x again, right? This is 2 root x, the uv form, right? First and the second. Here cos differentiation. So can I take the 2 out and differentiate like a uv form? I hope you will, especially 21 batch, complete the lessons here. 2 uv form, right? The first one, differentiate the second, plus write the second one, differentiate the first. So therefore root x, first one, differentiate the second, dy over dx, differentiate again, that's we call d square y over dx square, d square y over dx square, plus write the second one, differentiate the first one. Root x differentiation is 1 over 2 times root x. So I'll just left hand side completed as a UV pattern. Write the first one, differentiate the second, plus write the second one, differentiate the first. Okay. And here after the other side, cos theta differentiation minus sine theta. Hereafter root x differentiation 1 over 2 root x. So this is the answer available here. You have to pick up, take out from the answer. So how it is? Can I multiply by once again, or multiply 2 here, multiply 2, or multiply 2 root x, multiply the LCM 2 root x here, it becomes 4 root x, okay, into root x d square y over dx square plus dy over dx into 1 over 2 root x, okay? And the other side I multiplied by 2 root x, therefore it's become 4, right? 4 into that. But it is minus sine root x. Okay, the answer provided. In the answer, no sign, right? Okay. Now you can write y is y, no? This is y. This is y. It's better say y here, right? Now multiply the 4 root x inside, multiply the 4 root x and see the 4 into root x, that's x. D square y over dx square. Again multiply the 4 root x inside, root x cancel. 4 divided by the 2 here 2. Minus y that side. You can go to the answer. This first video, second video. First question, successive differentiation. Second problem, if y equal a cos log x, a cos log x, y equal a cos log x plus b sin log x, plus b sin log x, right? Plus b sin log x, a cos log x plus b sin log x. Then show the answer is x square d square y over dx square plus x dy over dx plus y equal to 0. Another problem, my second question here, successive differentiation, second times, 2 times, y equal a cos log x plus b sin log x, then show this answer. So like earlier one, first you differentiate the first occasion, hence go to the second differentiation. So you can see this, right? Therefore I start the dy over dx. What is dy over dx? That means first time differentiation. Yeah, a is a constant, b is a constant, right? A into, therefore a into, what is cos differentiation? Minus sine log x. Cos theta differentiation minus sine theta. Okay, hereafter inside log x differentiation 1 over x. Log x differentiation 1 over x, right? The other one positive b sine, that is b into sine differentiation cos, that is log x, right? Log x. Hereafter inner function log x differentiation 1 over x. This is first time derivative, first differential coefficient. Now multiply x, multiplied by x everywhere. So x into dy over dx, okay, equal to, here what, minus a sine logarithm x, log, or the basis e comes a ln, right? And here what, plus b cos logarithm x is the first differentiation. Next the problem is again second differentiate. So write second again derivate respect to x. Differentiate with respect to x. This is uv form. It's a single, only one differentiation. You also want, you can go to the answer from there. Therefore, uv form, write the first one, differentiate the second one. Dy over dx, differentiate, again we call d square y over dx square, d square y over dx square, plus write the second one, differentiate the first, x is 1, right? So here what, minus a sine differentiation cos theta, that is log x. And hereafter log x differentiation 1 over x, I write the x here below x, right? And come here cos differentiation minus, there's a b sine theta, sine logarithm x, okay? Hereafter log x differentiation 1 over x. That's all. Now you can pick up out the answer from this statement. So multiply x everywhere, multiply the LCM x. So here's x square, right? X into x square, d square y over dx square. Here multiply x plus x dy over dx. And how this one minus a, take the minus out, take the minus out. So a cos logarithm x, a cos log x, okay, plus b sine log x, right? Take sine b out, that is minus out. Then sine logarithm, I write here, logarithm x. So now check the answer. That is y. See here, it's y. That's given y. So put here y, to put it here y, and take this side become plus y. Therefore the answer x square d square y over dx square plus x into dy over dx plus y. It's one of the exam problems. If you covered clearly the differentiation syllabus from all the standard differentiation, then it can be done clearly. If differentiation clear, only you can go to the integration chapter. If this is failure, integration failure, you can't do integration problems, differentiation problem, and their applications also. So calculus, the best important proper part in the AL combined maths. Also university first year differential equations come a lot of problems. Everything involving the integral problems, integration, and hereafter its applications. Okay, so I show the third problem. If y equal cos inverse x all things square plus all important problems a cos inverse x plus b, right? Then show the answer is successive differentiation. So the answer is 1 minus x square d square y over dx square minus x dy over dx equal to 2, right? Another problem using successive differentiation. So first time differentiate and again differentiate, then you have the answer. Now the first time differentiation got complicated here. First differentiate the power, then differentiate the inside. Here differentiate the cos inverse only, where a, b are constant value near tie, right? Therefore you know that constant differentiation is 0. No values for constant differentiation, that is 0. So I write dy over dx, dy over dx. So what is that? Power, first you differentiate the power, then differentiate the inner function. So what is power differentiation? 2 cos inverse x, part of answer. Hereafter inside, what is cos inverse differentiation? Minus 1 over square root of 1 minus x square, right? Minus 1 over square root of 1 minus x square. I hope you covered this everything successfully. And positive here a, again cos inverse differentiation, minus 1 over, so I write the below, 1 minus x square plus b is 0. In differentiation, constant differentiation, answer is 0. Okay, therefore to get the answer, better you multiply everywhere by the LCM. Multiple by the LCM, that becomes square root of 1 minus x square into dy over dx. And what is this answer here? Minus 2 cos inverse, minus 2 cos inverse x minus a, right? Minus a, there's no b in the answer later, there's no a also, see? So step by step, all these constant terms are vanishes. Next, again differentiate. Differentiate again respect to x. Differentiate again with respect to x. Here uv form, here only single term. You know a answer is 0, right? Therefore, the uv form, write the first one, and differentiate the second. Dy over dx, differentiate once again, that's called d square y over dx square. Okay, plus write the second one, differentiate the first one, square root differentiation, 1 over square root 2 times square root, right? 2 times square root. Okay, write the first one, differentiate the second, write the second one, differentiate the first. Square root differentiation, 1 over 2 times square root. And inside differentiate, 1 is 0, minus x square differentiation, minus 2x, right? The other side, what? Minus 2 cos inverse differentiation, minus 1 over square root of 1 minus x square. It become plus square root of 1 minus x square and 0, a is 0. I hope you need the answer. Multiple by the LCM, multiple everywhere by the LCM. So 1 minus x square square root, multiple twice, no square root, the answer. And next D, see here 2 cancel, plus into minus, minus x into dy over dx, and here 2 available, right? This is the answer here. This is my third question. Next, my fourth problem. If y into 1 minus x equal to x square, then show that 1 minus x d square y over dx square minus 2 dy over dx equal to 2. My fourth question here, my second video for successive differentiation. So please newcomers, subscribe this and press the bell sign. Then you can see my all videos. I publish many vectors, coplanar forces, quadratic equations, some trigonometric problem, limits questions. I complete nearly 100 limit problems. So to show this answer that is given and prove this answer. So here there is second derivation available. So first time differentiate, then again differentiate. So if you follow in this order, it should be UV form, here only single form. Otherwise, if you multiple the bracket also easy, you can defer that. So I write UV form, write the first one, differentiate the second, 1 is 0, minus x differentiation is minus 1, right? Write the first one, differentiate the second, plus write the second one, differentiate the first, y differentiation is dy over dx, right? But the other side, x square differentiation is 2x. That is UV pattern, okay? Or then I can say here minus y plus 1 minus x into dy over dx equal to 2x. That's all this first differential coefficient. Now we derivate again, right? Next you can write a sentence, differentiate again with respect to x. Differentiate again with respect to x. Then follow, then get the answer. Differentiate again with respect to x. Here only one, there's a minus. Y differentiate respect to x is dy over dx. There's a minus separately. Plus come here UV form, right? So write the first one, differentiate the second, dy over dx, differentiate again, that's we call d square by over dx square. Write the first one, differentiate the second, plus write the second one, write the first, differentiate the second, plus write the second one, differentiate the first. What is first differentiation? 1 is 0, minus x is minus 1, okay? The other side, 2 times x is 2. Or maybe this is the answer. Is it? Check will you? The answer. First we write this one. 1 minus x d square y over dx square minus dy over dx, again minus dy over dx, that is minus 2 times dy over dx. Is it equal to 2, right? That's the question. My fourth successive differentiation problem. I guess the 14th question, because I mentioned already 10 problem in earlier videos. Next question number 5. If y equal e to the power m tan inverse all power, right? Everything in power. If y equal e to the power m tan inverse x square, then show this 1 plus x to the power 4 d square y over dx square plus 2x into 2x square minus m into dy over dx, a long answer, dy over dx minus 2my, right? Minus 2my equal to 0. Long expression equal to 0. And derivate first time and go to the second derivate. So first differentiation, right? y equal e to the power m tan inverse x square. So here differentiation is first to differentiate the e to the power x is the same, no? E to the power differentiation is e, integration also same, right? And the inner function. Very useful, a lot part here. Dy over dx equal e differentiation is e, right? E differentiation is the same. Okay, first part is over. Differentiate the e first. Next, inner function, right? That means power. Differentiate the power all into. So what is m? Tan inverse differentiation, 1 over 1 plus x square, tan inverse x differentiation is 1 over 1 plus x square. If it here x square, the square of that is power 4, right? Power 4, that is another part. Here after inner function, x square differentiation 2x. So there are 3 parts in the first differentiation. First differentiate the e to the power. Next differentiate the inner function, right? Now better you can multiply this LCM here. 1 plus x to the power 4 into dy over dx. Okay. Here what? This is y. This is y. This is y. See that's why. If I say y here, 2 there, x there, m there, right? 2mxy, okay, 2mxy. That's all the first differential coefficient. Now again differentiate respect to x. Again differentiate with respect to x, okay. Here uv form, I also you have the uv form, right? Therefore, write the first one, differentiate the second, dy over dx, differentiate once again, that's called d square y over dx square, d square y over dx square plus write the second one, and differentiate the first one. 1 is 0, power 4 differentiation is 4x cubed, right? UV form is over. Next come here, 2m is a constant. Inside x and y differentiation, UV form, right? So write the first one, differentiate the second. Next plus, write the second one, x differentiation respect to x, that is 1, okay? That is 1. So I think it's the answer. Check with the problem, rearrange it. So here 1 plus x to the power 4 into d square y over dx square. Now you count totally how many dy over dx are available. Here 2mx dy over dx. Here some few parts. Can I take common and out? That is, can I take the 2x out, then 4, 2 out, and the 2 available. X cube, x is out, therefore x square. And he will take this one here, 2x out, minus m. Okay, check the answer, into dy over dx. Okay, at last what? 2my, take this time, 2 minus 2my. Therefore, this is the successive differentiation, my second video. I published 10 problem, the earlier one. That's my classroom activity. This is the second 5 question, right? It's totally nearly 15 problem I shown. So I hope you understood this. So next, expect me some more applied lessons to AT graph, relative velocity, SHM, everything published through this my YouTube channel. Okay, nice to view this, and please newcomers subscribe and press the bell sign, then you can get more attractive videos, right?